Hi, Dr. Caps. My name is Travis White-Velez, and this is week 3's experiment, the acid-base reaction experiment for my advanced interactive concept presentation. For this experiment, you will need baking soda. I'm utilizing a spoon, just a normal piece of paper towel, a mason jar for the reaction to take place in, and vinegar. I will get back to you with a little bit of background for this experiment as well as the experiment itself. Stay tuned. All right, now that I have the supplies gathered, I am going to place the paper towel inside of the mason jar. And then I'm going to place baking soda onto the paper towel. All right. So as you can see, I have baking soda on top of the paper towel. And now I will pour the vinegar inside. And just put it in the frame. There we are. And there we have it, our acid-base reaction. I will be back in a moment to explain why what just happened and give you a little bit more background about acids, bases, and how they interact with one another. Now that I have completed the experiment, I will explain what happened and why what happened. So just a little bit of information and some definitions. An acid-base reaction is a type of reaction that happens when you have two solutions. One is an acid and one is a base. They then come together and combine, and you get what's called a neutralization reaction. Our book defines a neutralization reaction as a reaction between an acid and a base. And typically it's an aqueous acid-base reaction, which produces water and salt, which is an ionic compound made up of the cation from the base and the anion from the acid. Our book also uses Bronsted acid, and it's defined as a substance that's able to donate a proton, so in this case a hydrogen ion, and a base is one that accepts that proton or hydrogen ion. So the materials we utilize, the baking soda and the vinegar. The baking soda contains sodium bicarbonate and the vinegar contains acetic acid. So the acetic acid is also a very, very weak acid. There's a chart in our book. I forgot exactly what page it's on, but vinegar is actually not even listed. And it kind of goes from from your weakest acids to your strongest acids. Vinegar is so weak such that it's not even listed on that chart. Sodium bicarbonate is found in the baking soda, and it's a weak base. So you have a weak base and a weak acid coming together. So with this reaction, the neutralization happens because the hydrogen ions from the vinegar react with the sodium ions that are in the bicarbonate and the baking soda, or the sodium ions and the sodium bicarbonate, which is in the baking soda. The result of this is two new chemicals are then formed. You get carbonic acid and sodium acetate, and salt is produced. The chemical reaction or the equation for it is given as NaHCO3 plus HC2H3O2, and that will yield NaC2H3O2 plus H2O plus CO2. So essentially, sodium bicarbonate plus acetic acid will give you sodium acetate, water, and carbon dioxide. I hope that explained a little bit more of the reaction. Also, the carbon dioxide was released in the form of the bubbles. Because bubbles break through the surface of water, the gas travels upward to a point where there's no resistance. The bubble pops and releases the CO2. I hope that explained this experiment a little bit more. Thank you for your time, and I hope you enjoyed. And also, just to mention, the pH scale, which is essentially how to determine how strong or how weak an acid is based from 0 up to 14. The closer you are to 0, the more acidic you are. The closer you are to 14, the more basic you are. So in this case, 7 is kind of that neutral number on this scale. And it's just important to note that acetic acid actually falls somewhere around the 4 to 5 range for its level of acidity. Even with that being said, if this experiment's being done at home, you still just may want to watch out for just some irritating of the skin if you have sensitive skin. Other than that, that was a disclaimer I wanted to add. Thank you.